Okay, this is the homework help video for Honors Math 3, Unit 7, Worksheet 4. And I'm going to start with question number 16. So for question number 16, the first thing we want to do is we always want to isolate the exponential. So what that means is I want to get e to the x plus 1 by itself. So I want to get the 9 to the other side and the 1/2 to the other side. So I want to first start by subtracting 9. So I'm going to subtract 9 to isolate. So then 1966 minus 9. And then I still want to get rid of the 1/2, so I'm going to multiply by the reciprocal. So I'm going to multiply by 2 over 1, which is just 2. And so this will reduce down to 1. And then 2 times 1,957 is 3,914. So I'm just doing that in my calculator. And then from there, I want to get x still by itself, right? So I have the exponential isolated. So now I need to get rid of the base of e. So to get rid of the base of e, I want to use a log with the same base. So log base e is the same as natural log. So I'm going to take the natural log of both sides. So I have the natural log of e to the x plus 1. And then the natural log of this as well. And so right here, these are going to end up canceling because what power on e will give me e is 1, and then I can pull that down, right? So that ends up canceling, and then the power comes down, so then I have x plus 1 equals the natural log of 3914. And then from there to solve for x, finally the last step would be just to subtract 1. And so just for the sake of space, I'm going to do that down here. And then when I subtract 1, I'll have the natural log of 3914 and then minus 1. So the 1 is not subtracting just the number, it's subtracting whatever that whole value is. So I'm going to go ahead and group it just so that we understand that the 1 is subtracting that whole value. And then from there, I would just type that into my calculator. So I'm going to just show you on a graphing calculator. So you might have like a different calculator, but this is the one I'm going to show you on. So I want to find a button that has a natural log on it. So for mine, it's right here by the 4. So I'm just going to press natural log. And then the value itself, so 3914, close my parentheses. And then from there, I would subtract 1, so then minus 1. So again, make sure that that 3914 is open and closed, and then minus 1. And then we want to be to the nearest thousandth, so then that would be just 3 decimals, and so that would be my answer there. So that was 7.272. And so we have to have both answers, the log version and the decimal. Okay, and then let's take a look at number 25. So for this one here, so this one's done totally different, right? So lots of different ways to start out. So I usually will start by clearing my fractions, but I'm going to wait for it to focus first. So I zoomed in too fast. So I'm going to clear my fractions. So I'm going to multiply both sides by 3 to the x. So it will cancel here. And then I need to be able to combine these two together. So the only way I can combine them though is if the bases are the same. Like I can actually multiply these together because I have the same power of x, but that doesn't end up helping me out. So I want to go ahead and get a common base. So I know that 9 is the same as 3 squared. And since 9 is to the power of x, 3 squared also has to be to the power of x. And then I'm going to do the same for this side as well. So again, 9 is the same as 3 squared. And since 9 is to the power of 2x minus 1, 3 squared also has to be the power of 2x minus 1. So all I did was get a common base. And so then now I'm going to go ahead and simplify my powers here. So I have 3 to the x still. And then power to a power I multiply. And then here I want to do power to a power multiply. So I'm going to distribute that in. So 2 times 2x minus 1. So 2 times 2x is 4. 2 times negative 1, negative 2. And then finally here I have my common bases, so I can add my powers together. So whenever we're multiplying, we add, right? So I have 1x plus 2x. And then a couple ways I can think about this is I know I need to get rid of my base 3, so I could do log base 3 on both sides. But I also know that in order for these to be equal to each other, since the bases are already equal, the powers just need to be equal. And so then I can just write that as my equation of just my powers. Or if I think of it as log base 3 on both sides, that would cancel. And then from here, just do your normal solving. So I want to isolate the x, so I'm going to group those together. So I'm going to subtract 4x to both sides. And then that will cancel. And then that gives me negative 1x equals negative 2. And then when I divide both sides by negative 1, I would get x is equal to 2. Okay. All right, and then let's take a look at a couple on the back side here. Okay, so let's go ahead and take a look at 31. So for this one right here, so I want to isolate the exponential, which it already is, and so then now I need to get rid of the 2. So I'm going to go ahead and do log base 2 on both sides, because I want to get rid of base 2. So then 2 to the power of 2, or excuse me, 2 to the power of 1 is 2. So this would end up being just 1 or canceling, and then that would come down. And then here, I don't actually need my calculator because I can do this one. So what power on 2 gives me 32, and that would be 5, so 2 to the 5th. But because it's a fraction, it should be negative, so that would be negative 5. And then because it's quadratic, I want to make sure that it's equal to 0. So then I'm going to add 5 to the other side to equal it to 0. And then as soon as I have that, I want to factor it. So I'm going to look at my groups here. So x squared is x times x, and then I'm trying to figure out what would multiply to 5 and add it to negative 6. So that would be 1 times 5, and then both would have to be negative. And then set each factor equal to 0, and then solve. So I'm going to shortcut this just because of room. So x minus 1 equal to 0, that would be 1. And then x minus 5 equal to 0 would be 5. So I would have 1 and 5. Okay. All right, and then let's take a look at a couple of word problems. So let's look at number 37. So first I just want to do a quick scan and find all the numbers. So I have $1,000 here. I have 4%. And then I have 2,500. So I'm not even reading the problem, I'm just looking for my numbers. And then once I do that, now I'm going to go ahead and read this. So I have $1,000, and that's invested at 4%. So the 1,000 is the money I'm giving to the investment, so that would be my principal amount, so that's P. And then I'm investing 4%, so that's my interest rate. Excuse me, I'm invested at 4%, so that's my interest rate. And so then as a decimal, that would be 0.04. And then I'm compounding, but I'm compounding continuously. So then that formula is that, and so that should be on your notes somewhere. Oh, but I'm looking up here. It's also at the top here. So this is the continuously one, and then not continuous. And then now we want to know how long it will take, so we're looking to find T. And then for the money to get to this value. So that would be our final amount, or A. Okay. So I have the value for P, R, and A. So then I'm going to just use the same equation here, and I'm going to replace it with the number values that I found. So A, I'm going to replace for 2,500. And then P, I'm going to replace with 1,000. And then E stays E. And then R is the 0.04. And I don't know T. So then from here, I'm looking to isolate the exponential. So that means I want to get the 1,000 to the other side. So I'm going to divide by 1,000. And that gives me 1. So then when I divide that, that would be 2.5. Oops. And then I want to get rid of the base of E, so I need to do log of both sides, base E as well. And so log of both sides with base E is natural log. So then I'm going to take the natural log of both sides. So if I pull that down, natural log of E is 1, right? So that's going to end up canceling just to give us 1. So then I have natural log of 2.5 equals 0.04t. And then my last step is to finish solving for t, and so I'm going to divide by 0.04. And so then t, when I do that in my calculator, so I would just type that into my calculator, so then I would get 22.907, and then that would be in years. Okay, and that's it for this video.